change, we will not be in the situation where we are today. We will not be at all. And coincidentally, the guest speaker, engineer Ayo Fanimo, engineer Chimufalui, Evidence NIMechE, is working on one of the refineries, to be precise, Port Harcourt refinery. He's supposed to be here today, but he gave a call yesterday that he had an urgent meeting with the management of that. They are working on how to maintain that refinery, and by God's grace, the next few months, it will become functional. We are happy that he is not available today, but he has sent another mechanical engineer who is also one of us, a capable hand, to handle the presentation he has for us. And his representative, as he has announced, is engineer Femi Ogunseyitan. You are highly welcome, sir. He's going to do justice to it. Apart from that, our Oba is going to be one of the discussants. Likewise, our national chairman. So let us listen attentively to what they are going to discuss, and not only listening, let us have a take home that we can send to the relevant authority, so that whatever we are saying today, whatever we are doing today, is going to add to national progress. Not to just come and sit down here, talk and disperse. No, we want a take home. That is our plea. Thank you very much for listening. Thank you for coming. We hope that we are going to enjoy ourselves. Thank you very much.
I want you to give our chairman a big round of applause. So for our chairman, today is also supposed to be the day of Thanksgiving for all of us. Yeah, the day of Thanksgiving, because he has gone through, some journey and has come back. So we thank God for you, and we're happy that you are back and now strong. So quickly, as you said, we have a limited program this afternoon. This morning is already afternoon. So as we said, this speaker is being represented here today. But however, we still want us to know our this speaker, who is he? Although he has sent a representative, but who is he? So I will call on our member, engineer Danimo, to please quickly come and read the citation so that we know the caliber of the person that we have asked to come and speak to us. Over to you.
Standing on the sitting protocol of first, my glass to Oba. My glass to Oba, thank you for honoring us, sir. Remember, sir. Can I call the representative of engineer Chimufalui, well represented by engineer Femi Ogunseyitan, to be outstanding, while we confirm the pedigree of engineer Chimufalui, well-renowned standard and code expert. He's a current registered engineer. I quickly summarize because he's not here. He's the member of NIMechE, a past chairman of Lagos chapter of safety. He has so many degrees, including a member of Harvard School of Business. He's a founder of many business. Part of it is offshore dimension, who is into a lot of pneumatics products, hydraulic products, gas and air operated products. Presently is running a major project in Port Harcourt as well. And by the time the refinery is coming on, know that we have one of our experts being involved. Although he promised us, but he's well represented here. He's also an international man of all standards And one of his major fields, as I've said, is code and standard. He's happily married, a blessed man, an economist, and married with 3 children. I here present to you, as represented, Engineer Femi Ogunsetan on behalf of NIMechE Lag to present the main lecture for today. Thank you, sir.
Um, Good afternoon, sir. Um, Thank you all for coming. I want to have is all protocols duly observed. Our former chairman, all our elders, I greet you. Okay, so I'll just do a quick introduction of myself. I have a presentation, but my laptop, the compatibility with that projector that want to connect to buy what we used to fix it here. So the lecture I have some slides which I'm going to present. So a brief introduction. Okay, sorry, let me begin. Okay, so a brief introduction. My name is Oluwafemi Osheito. I'm also a mechanical engineer. I work closely with engineer Shinfani. Currently, he was supposed to be here today, but he had an urgent call, a national call. He's representing our organization at the Port Harcourt Refinery, so he had to travel yesterday urgently. So I work closely with him. We are contractors working on the Port Harcourt Refinery. We are working with the main contractors. It's a company called Techinons. Techinons is an Italian company. The original people that built the refinery was a Japanese company. So Technical bought over the Japanese company, the patents for Port Harcourt refinery. So in the last administration of President Muhammadu Buhari, when the idea came up to revamp the refinery, one of the things that resolutions was that they decided that they would go to the OEM, that's the original equipment manufacturer. That is the original people that built the refinery. So they went back to them. And that's why the second month came into play. Although there were other bidders to revamp the refinery. So with the refinery project, I'll just give a brief introduction. This is the revamp phase. There were two. There was a phase before called a survey phase that was held I think 3 years ago. A survey phase was done by also Technos and us. The organization which we work for is called Pivot GIS. So the survey phase was to go around the refinery and do a proper assessment of things that were down or what needed to be revamped in the refinery. So there was a survey, they brought experts, destructive tests, non-destructive tests, mechanical handlers to check in detail. And that survey, which took like 6 months, is what was used now. The data from that survey is what was transferred into the engineering phase of for the project. So the engineering phase was done both here in Nigeria and also in Europe. They came out to see what was done by technicals to see exactly what are the things that need to be done. So most of the equipment, some of them I will give you the presentation, were then procured. They went to the procurement stage where they bought some of these materials both locally and internationally from majorly the original equipment manufacturers, the OEMs. So that's when the revamp project started in earnest, sometime earlier last year was when it started. Um, as we see, the refinery was based on areas 1, areas 2, areas 3, areas 4, and areas 5. I think the area 5 is the most. So when you say an area is a complete module. That is a complete section of the refinery that produces refined products and exports it. So the areas are almost semi-autonomous, as in they are developmental stages of the refinery. I think they did area 1 and 2 and 3 initially, then they went to area 4 and then area 5. So area 5 is the newest component of the refinery. And that is the one that the federal government is targeting to start production by December. And that's what they are working on. So I'll give a few presentations to show progress on the refinery. Right now, the importance of the refinery cannot be overemphasized. We see the cost of refined petroleum products in Nigeria, the effect of subsidy on our economy, um, a lot of things that if the refinery goes into workforce, into full operation, will benefit the country. At the full operation of that refinery, you have 20,000 people working in that refinery, both directly and indirectly. So even the refinery will provide employment opportunities for Nigerians and also mainly for mechanical engineers that will be working in the refinery. Thank you. So okay, okay, so the refinery, I'll just give a summary. So the way the approach of the refinery, it's a brownfield revamp work. That's what is going on now. It's a brownfield refinery revamp work. So the areas 1, 2, 3, 4, and 5, like I said. So the strategy for fixing the refinery has been that specialized equipments are classified together. You understand? For example, um, the boilers. So the equipment in the refinery, the way it's being revamped, specialized equipments are classified together. The boilers, the areas 1, 2, 3, 4, and 5 are classified together. So there's a work for boilers. The heat exchangers for all the areas are classified together, heat exchangers. The cooling towers, because they are all replica equipment. So the approach is once you are fixing the heat exchangers, you take care of all the heat exchangers. When you are taking care of the boilers, you take care of all the boilers. When you are taking care of the cooling towers, you take care of all the cooling towers. So we see some of those equipments and how they are laid out when I do my presentation. Then also there's a lot of civil work also going on. A lot of those things are repair institutes. You understand? While the equipment are there, civil works are being repaired, removed, and replaced. A lot of painting, fabrication work also is being replacement of piping networks in the plant, replacement of critical equipment, procurement of equipment, and several other things that is going on in the refinery. Sorry, let me just. Okay, so you just help me. So today I'll be giving a lecture on asset integrity management, a case study of Port Harcourt refinery. So, um, like I said, the um, lecture for today, the importance of today's lecture is to focus on uh, uh, mechanical engineers, our contribution to maintaining national assets, how our role in national development through maintenance of critical assets. So I'll be talking about asset integrity management. I'll just give an overview of refining process. We are not refiners, we are EPC contractors. And then we'll discuss a look at what the Port Harcourt refinery is, the potential, what Port Harcourt refinery brings to the table for Nigeria as a country. Then I want to show some of the rehabilitation works and structures. Then I will show the current status where we have in Vampida refinery. A lot of debate has gone nationally when the president said that it's ready by December. there was a lot of skepticism that it won't work. They have tried. So, but you will see from here that there's a lot of work that's actually going on in the refinery to make it work. And then, much more importantly, and the other side that we should discuss lessons learned. So that's an information we can pass to our fellow mechanical engineers so that in similar projects, maybe any of us will have the opportunity to work on similar projects. We will take notes of some of the challenges and then we can avoid the pitfalls unleashed onto some of these things. Okay, so asset integrity. Now, for oil production, like we know, there's exploration and production. Exploration are the people that drill the well, uh, and then they produce it. There are several ways we to produce oil. You produce through FPSOs, offshore platforms, onshore process facilities like gas plants and oil fuel stations. And then the next thing is when you have crude oil, you know that all of us know that crude oil cannot use it for our cars or our engines. It needs to be refined. So the next one is refining. You need to refine it. And then after refining, and that critical thing is you need to process it. In the place of refining, there are a lot of things that you get from refined raw products. You need to process it for use place. And then the last one is you need to distribute it. Nigeria needs to invest in all these critical infrastructure. Right now, in Nigeria, we have a lot of problems distributing petroleum products. That's why you see tankers going up and down the road where we can lay pipelines all around Nigeria. If you go to London, gas goes to every home by small pipelines. They don't have gas bottles like we buy in Nigeria. So, in all these areas, there are where mechanical engineers can contribute and further improve national assets and facilities to further increase our efficiency nationally. Then, majorly in the refinery, like I said, you have the piping networks, critical equipment, you have the structures. That's the structures, steel structures that hold the refinery around. Then you have the pressure vessels, you have static equipment, you have rotating equipment, you have instrumentation. Then most refineries they have offshore components. That means vessels actually come there to base, take refined products and export. Um, and then you have onshore also facilities onshore. Next slide, please. So the core elements of integrity, asset integrity. Um, if you want to maintain your equipment, if you maintain your equipment, and that's when your equipment is in a constant well maintained, in a constant functional state, then we say that your equipment have integrity. So now to focus on that, it's like a plan check and act cycle. We say HSE critical equipment and performance standards. The first thing you consider in the refining petroleum chemical plant is safety. So you cannot refine petroleum products compromising people's health, safety, and standards. It will be interesting to know that um, in a refinery, we have a lot of um, what we call produced water that comes from the refinery, which is contaminated. So this has to go through the treatment plants before that water is introduced back into the environment. So government agents actually come to test water that the refinery, each refinery passes back into the environment, into the rivers. So this is so HS is very critical. I know for when you store petroleum products like petrol, all kind of hydrocarbons, they are highly flammable. So safety is a very, very critical. When you do risk assessment for everything you do in refinery. So HSE critical records are also very important. You need to take records, you need to analyze these records and use them as to take strategic informed decisions going forward. Then integrity review, you also need to constant integrity review. Then inspection, test and examine. You need to constantly test and examine. There has to, for everything you deliver in a refinery, there has to be a detailed, established acceptance criteria. If you lay a pipe or you weld two things, there has to be a test that shows that this thing is acceptable. And then, even right now, in the world, in the maintenance world, we are doing corrective maintenance, preventive maintenance, predictive maintenance. Right now, what is predictive maintenance? Where you don't want reliability of plants right now is that no short-term time at all. And when you use that, you predict. One of the ways which you predict is through the inspection and testing examination. Right now, we have infrared equipment that if you put it on the equipment, you can show the heat output. If it goes beyond a certain threshold, then you know that that equipment is not functioning properly. Then we have the assurance, verification, and certification. Yes, you need to assure, verify, and certify critical equipment. Even if you want to have a lift equipment, you want to use a lift equipment, for example, you need to verify and certify that it's fit for usage. And then the next one is management of change. Yeah, how you change, you change in finally when you are doing this kind of thing, it's very critical. Um, Change is one of the critical things because as you see in the slides going forward, many of the equipment that were used when the refinery was built in 1960 something are currently obsolete. Modern technology has gone, so there needed to be a re-engineering to adapt new technology, new environmental standards, compliance issues. So how you manage these issues is also very important. How you manage those issues. Next slide. So current integrity issues across our life cycle, constraints, cost constraints for regulation of design. Protocol refinery has been in existence for several years. There needed to be a modified design that will accommodate and bring it back. And I can tell you, sometimes you find that fixing an existing plant which is dead is sometimes difficult than building a new one because your principals, which is NNPC, they are cost focused. When you go and say, you cannot go and meet your client and say, good afternoon, I want to replace the whole refinery, I want to bring out everything and buy a new one. You understand? So they are very focused on what is still useful, what comes out of it. So cost element is very, very important. Non-compliance with procedures to meet schedule, poor quality workmanship. Okay, so a critical thing, like I said initially, is schedule. The three things of any project is cost, quality, and time. Like I said earlier, the federal government has mandated us to finish this project within specified time. And sometimes you have a lot of constraints that makes it difficult to achieve those very strict timelines. One of it is the quality of workmanship. I can tell you before Dangote refinery came up, there had been a vacuum in development of refinery in Nigeria because there were no refinery projects. So to get the right skill, requisite skill to meet the requirements to work in that refinery was also an issue. And then we had local content requirements to meet, where you need to have local workforce to a certain threshold. It's not that okay, you have a project, just go and bring expatriates and start using them. So compliance issue is very important. Then handover of non-startup critical packages, non-compliance with procedures. I should have first work at the first shutdown, revise maintenance strategies and catch up. So another one is the handover. The plan is that when that finally is finished, they will now hand over to an operations and maintenance organization. So the plan is not before, particularly refineries in Nigeria, they were managed by NNPC staff. So but now there's been a new structure. There will be somebody who will become experts, who will come and operate and maintain those refineries. So NNPC will just oversee what they are doing to ensure that integrity of the plant is kept intact and is well maintained and operated. Next slide. So another one is new technology on time to existing infrastructure. Like I said earlier, Nigerian refinery is very old. If you go to modernized uh, refineries, you see, before there was a generator we were working on in Port Harcourt, so technicians were working on it for me, and they kept putting oil into the generator, and so I checked that police generator online, and I found out that it's 40 liters of oil, and they kept requesting for 60 liters of oil. So I now did an analysis of why are they putting. I even thought maybe they are stealing the oil because a 40-liter song, I mean, you are putting 6 liters. But when I checked, it's an old equipment. I now found out that the new generators of today are much more efficient, they are smaller and have higher outputs. They are more efficient. So equipments evolve over time, and then there are international developmental standards, compliance standards, innovation, impact. You understand? Before you have very big equipments that will cost so much. Now you have smaller equipments that will cost less to handle, to ship, to maintain, and they are much more effective. So other things now, but the refinery we have in Port Harcourt is an old one, which we want to infuse a new technology into. So that compatibility between the two, the old and the new, is also a critical engineering that needs further engineering. And then you want to be cost effective as much as possible. So, and then, like I said, some of the equipment in the refinery are all obsolete. That's the truth. Some of it are obsolete. A lot of things that get to be engineered, revamped, abandoned. So then new equipment in the field conditioning. So another thing is that, like I said, yeah, new equipment in the field. You understand? A lot of technology. In the world now, they have done a lot of business process engineering, where you do a process analysis and then you take off relevant processes to make it more efficient, more profitable, more fast forward. So these are the kind of things we are encountering there. Integrity required for lifting equipment, required for clearing. Also, so we have some in a place like Port Harcourt refinery, we were built to you have very big columns. We see some pictures as as we proceed. You need sometimes 8 ton crane, all those truck crane, very very big cranes to lift those towers. And some of those lifts need actually need lift design for it. You need to talk to the manufacturers of those equipment. You need to talk to the lifting company. So a lot of critical issues that we are facing in the refinery. Okay, so this is the refining process. Like I said, we are not refineries. The basic people that do this are process engineers, from refining process all the way to refined petroleum gas, liquid petroleum gas, gasoline, solvents, kerosene, diesel, heating oil, lube oil, greases, house fats, industrial fuel, and coal. So these are things that come out from the Port Harcourt refinery. In Nigeria, we have 3 refineries. We have the Warri and the Kana refinery. It's interesting to see that even the Kana refinery, our refineries have a bit of variance in what they produce. The Port Harcourt refinery, Kana refinery, for example, produces lube oil production, and because they have a tin plant there, they manufacture tin, drums. They can manufacture drums. They do lube oil there. Next one. Oh, very faint. Okay, this is Port Harcourt refinery. Okay, so let me just try and explain the Port Harcourt refinery. Sorry, here you have the areas 1, 2, 3, 4. You have the tank area. Um, there's a loadout area. There are 2 types of loadouts. There's the ship loadout and the tanker loadouts. Like we know that all those depot, like our depot, where they go, trailers go there to take refinery. And there's the tank farm. So the columns here, and they are area 1, 2, 3, 4, and 5, like I told you. So the areas is a complete module within the plant. That is, it produces cement independently. And then you have the central processing units here, where which processes, brings the oil, pumps in. There are vessels that berth at the refinery. They take either bring in crude or take refined petroleum as the case may be. So I was supposed to show you the color variance a bit. So then this is also the area. So for example, there are not 2 a typical area 3, just one of the areas similar to other ones to show us the basic processes of the refining process. Then this map, it's a typical map, engineering mapping of one of the areas. So what we use this for? You see the blue color items are items to be placed. So in the engineering that I talked, like I said, in traffic engineering, we identified what exactly needs to be placed totally. Then the red items are the ones that get to be refurbished. I hope you understand. So there are some of those equipments, they are totally bad. You need to take them out totally and then you replace them. So those ones, you go to the OEMs, you place an order Some of them are long lived, they are manufactured nationally and internationally, they are shipped, so you replace. Then there are some that will be refurbished. I will see as we progress also. Now, this slide is to show us that the way the maintenance work is structured, there's a layout in the way they're structured. From if you see, there's piping, there's civil works, there's erection, there's painting, equipment, erection. So there's a work breakdown structure in how those works are done, and they are all coded based on here. So you see erection, civil works, um, piping, instrumentation. So the instrumentation team, they have a team. The planning piping have a team, equipment have a team. So there's a work breakdown structure that they all work within their line, and then a team integrates what everybody does and managing. That's what we call simultaneous operations, managing those activities one by one. Okay, so um, this is just showing some of the pictures. There's a demolition works going on, excavation. Some of the concrete works are bad, so we excavate, compact, blind, iron work and foam work, and then curing and repairing. You can see this is one of some of the things, the foundation of some of the critical equipments. They are currently being removed and then replaced. Then anchor bolting, support for equipments and piping. Sometimes use anchor bolts to put them down to single structures. So this is part of it. Next slide. Still anchor bolting. This next one. Okay, so civil works also going on here, because one of the first things that you need to do when you want to set up equipment piping in a plant facility is first of all to get the civil works done. That's the base. After which you now start the mechanical and piping works. So for every instrument that you put in the refinery, their level is very important. Um, it's very important because there's a tolerance limit of tolerance limit, minimum accepted of tolerance limit. So those are things we do. Then of course for the civil works that are going on, you do some technical tests, like we said, inspection and testing. You do a cube, you have to check the cube strength, the concrete strength. Part of things we do. We did a lot of tests, not just testing, X-rays, ultrasonic testing, magnetic particle inspection, dye pattern tests. A lot of the testing that we do here. And then, okay, this is a point of concrete, for concrete, a preparation for the sequence. And this is the problem of concrete. Then pump replacement, like we said earlier, some equipment can get to be replaced entirely. An example are some pumps that have to totally taken out and replaced. Then static equipment, we have dropped tanks. They have a lot of tanks, storage tanks. The storage is one of the major facilities in the refinery. So those are static equipment. And then so the tanks and drums were needed to be opened, then cleaned, then API is inspected. There's an American Petroleum Institute, there's a standard for tanks to clean those tanks and then get them back to use. And then installation of internals and final box up. You install internals of the tank and then you box it up. And there's still a lot of maintenance work, painting, cathodic protection all around it. And then we have columns also. And the columns need to be opened, cleaned also, API inspected, installation of internals and final box up. So these are examples of static equipment that we're currently working on. And then some of them will also have the columns, like you see. You see a lot of them are rusted. A lot of painting, blasting work, opening them, changing the internal linings of the equipment, changing equipment around it, so rotating equipment around some of these columns. For example, inside the columns, you'll be placed with trays that these are people working inside the column in what we call confined space. There's confined space procedure for going to maintain replacing internals of some of those critical equipments. And then, so this is an example of one of the internals of one of the columns that's currently being replaced. And then you see things that were taken out, a lot of things that were dismantled, rusted, broken, all of those things that were identified and had to be taken out and then replaced. Next slide. So these are an example of some of the internals, the new items that were installed in the broken and rusted rooms. Okay, so another one very critical equipment that we have there are the heat exchangers and then cool towers, like I said. So the heat exchangers, you need to unbolt them, bundle pull it, you pull out the bundles, and then you clean the heat exchangers, then you are able to test. Okay, so hydro testing the equipment. Sorry, let me just. Thank you. Okay, so um, these are examples of the heat exchangers. So these are examples of the heat exchangers. Uh, these are this. Okay. Sorry. Sorry. Take some time. Sorry. Um, So, like I was saying, one of the other critical equipments we have here needed to go are the heat exchangers. Refineries, heat exchangers are very, very important to maintain the integrity of the plants. So, for the heat exchangers, what you do, you dismantle them, and then also you have uh, your bolts, you pull out the bond, it has a casing and the fins inside. You pull it out, you clean, and then you have to identify test. That is, put it under pressure to see if there are no broken cells and if it can work. It's a validation process to see whether it can work under working conditions, the working conditions. Okay, then also there's a lot of visual inspection before they are replaced. And then also for the air coolers, you have dismantle of electrical motors, dismantle of shaft and fan, blades, electrical motor supports, brackets and fan rings, dismantle of auxiliary structures, hydro tests, and then integrity checks also for the cooling towers. So that's also going on. Sorry. Okay, so these are examples of some of the heat exchangers. So you can see inside the fins, it's pulled out, and then what is being done on the internals. Next slide. So this is a heat exchanger, welding of bolts or some welding activities going on. Actually, there's a welder. They do some welding activities also at the refinery. So this is also an heat exchanger currently being worked on, and then these are the modules that are extracted from the heat exchanger. Next one. And this how you blast. You use a blasting jets, water jets, to clean out all the rusts, and then blast and then clean them up. And so that's the blasting process that is going on here, using water jets. Then air cooler banks also needed to hydrotect the air coolers, and then air cooler here to dismantle. Dismantling also is going on. So those are things that are going on. So I don't know whether we have any question, one or two, before I now go to lessons learned, or should I just discuss that? Okay. So some of the lessons that we have learned individually and as an organization. Number one is work methodology. The work with the breakdown structure, pivotal for focusing on lead value, leverage for execution. Okay, so uh, prior to working for my organizations, I've had the opportunity for working for an Asian company, a very big multinational corporation. And one of the things I learned from them is how to do a work breakdown structure. I tell people There was a time we were doing a tour of Kaduna Refinery, and we had a partner from the US or a refinery in the US that joined us on the tour. So when we entered Port Harcourt Refinery, one of the engineers who we interviewed at the Kaduna Refinery, after we left, the American told me so. They said that guy was being first class, and take that guy any day in the world, that guy is a first class. So going around my little years of experience is that we have very brilliant Nigerian engineers, extremely brilliant, world class, any class. But our problem is connectivity. That is coming together, having a strategic objective, right? Coming together to achieving a strategic objective. If you see the Asian company I work for, they'll pay you so small. But the work that one Nigerian will do pay work, they will divide it. Then what managers do is they integrate everything everybody does and makes it whole. So as a culture, this is one of the things we need to do. What is solid plants? You have civil, you have mechanical, you have instrumentation, you have welding, you have painting, plastic, a lot of things. So how to bring those different disciplines working simultaneously and towards the same cost, time, and quality objectives, coordinating them to achieve the strategic objectives is very critical in such. So that unity of purpose is something that the engineering arm in Nigeria needs to learn more, so that we bring our expertise into play, and then we can use it to achieve moving Nigeria forward. If you check every technology that we need individually in this country, the knowledge that we need, or who is the person that will bring it together, coordinate it, and then harness the benefits. I think it's one of the lessons that we have learned from this project. And then the next one is scaffold design. Um, that kind of complex. You know, this by some columns are 15 meters, 20 meters. For you to access it, you needed scaffolding. And to put the scaffold around the whole of Port Harcourt Refinery, I'm sure you know it's very expensive. You understand? So your scaffolding design, how you optimize scaffolding, right, is very, very critical. So one of the things that we deployed was we used mobile scaffolding as against those kind of fixed scaffolds that we see everywhere. And then the next one is contracting term and management. Term management. Nature of contract use was novel to many contractors. Okay, so the contract, so another thing that as engineers we need to learn is contracting. A lot of engineers are technical people. They don't understand contracting. So what we see is that in the Italians give you this table to work on and this table. So, and you deploy resources to do both these two tables. And at the end, they come and tell you, no, I only told you to do this one. So they really work based on call-off. So, very critical is that we need to understand contracting. That's what, as engineers, as mechanical engineers, I think somewhere we need to, when we need contracts, what informs our output productivity on site is contracting. A lot of people complain or do things that are not acceptable or do things that are not beyond contractual terms. We see a lot of indebted losses in some of those things that you do. When you miss a time and you have to pay a penalty. So it's also a lesson start. Then another thing is subcontractor management. You have so many subcontractors. If you are not careful, the subcontractor will destroy your work. You bring somebody to do something for you, maybe plumbing or something small, and then it's not doing optimally. So your own quality standards, your management structure, you need to transfer it to your subcontractors so that they meet the requirements of your clients. I think. Okay. Then community collaboration. I must tell you, one of the greatest challenges in working in Nigeria, I'm sure you all know, is community. You understand? So if you don't know how to liaise with community, collaborate with them, bring them on board, train them, develop their environment, it's very, very it will to have adverse effect on your development. So community collaboration is very central to your success. Then of course, motivation and employee morale. You understand? You need to pay people on time. International projects like this, you cannot afford to owe. You need to pay people wages that are commensurate to what they do. So, managing employees, you understand? Right now, you agree with me that during this refinery, you work into December during Christmas. You have people working for you in Christmas, how do you motivate and keep them working for you on the job? So it's also very important. Then cross-cultural team management. If you go to that refinery, you see Nigerians, Italians, Indians, Japanese, all Koreans, all forms of people in Yoruba, Igbo, Hausa, Shekiri. You understand? So how do you manage those cross-cultural issues? By 12 o'clock, some people need to go to mosque to pray. How do you manage those things into the management system? So those are critical things also cross-cultural management and training and cross skilling. Okay, so one of the things that we have attempted is to keep that technology involved. We use this project to train people and develop them. So this is another challenge that we have. Then recruitment errors when you bring people to do a work and they cannot do it. If you bring a welder to weld, you test the welds, all the welds are repairs. Then I'm sure you understand. It's a big issue. You bring a painter to paint, he mixes the paint, he does a paint of a color, and the second day the paint is to dry because he doesn't understand. So recruitment, you need to balance how you bring people in, get them off, bring people in. So recruitment is another thing that needed to be learned on projects.
Next slide.
Next slide.
We are already on next slide.
Okay, yeah. So working methods. Yeah. So like you said earlier, there are quota standards. Refinery, you're working to American API standards. So you need to understand these standards. If you want to work on a pressure vessel, which code governs that international code governs the pressure vessel? You understand? You want to work on a tank, which code governs tank? You want to work on piping, as we did at 1.5, which one covers it? You want to work on the pipelines that will take refined petroleum from the refinery to a location. Then you need API 5L. Understand? So all those critical codes, you need to understand them, adapt them, and go to those standards. If you do inspection to what standards. So standards and code are things that also can be very challenging when you are doing this kind of projects. And of course, KPI. You have critical key performance indicators. And one of it is time, like we said. Federal government has said they want that finally to work. So you need to set up your team, optimize so that those timelines are met and the timeline objectives are also met. And that creates one was first objective. They are giving you 500,000 naira to do the work. You won't come back to the client and say, I did it for 1 million. Where do you want the client to get it from? So you need to optimize, understand the work, while you're doing your pricing, your costing, and how you manage. Because you actually have so much money to do the work, but if you don't manage properly, you will see that by the time you are getting 50-60% of the work, you have exhausted your money, and that's it, which is one of the issues because most contractors they don't understand the technical intake, the costs part of it, and those are some of the suggestions we have also as mechanical engineering. We need to develop our cost management knowledge very well, where we can properly price using price methods in the bottom top so that the cost that we have for the project can actually deliver on those projects. Okay, so we have some safety indices here. It's not very clear. It's to show you that we have right now 693,370 man hours that we're putting in the project. And by God's grace, we can tell you that there's no lost time injury, lost time incidents, there's no injury, no fatality, nobody has been killed at the final. So very, very important. So thank you very, very much.
Thank you very much. Let's appreciate him more. But, we have so many mechanical engineers who are orators. If you allow him, the next 2-3 hours will not stop. So thank you so much. God continue to bless your knowledge and understanding. And there are 2 national assignments for all of us. It's a great national assignment. Let's continue to pray for them and support them. There are some people, they are always pessimistic. If you never work, it will never work. But based on what he has told us today, we have seen, if we have been reading online or where somewhere, one of us, the mechanical just like us, is assuring us that come December, by God's grace, all things being equal, the refinery will work. And that will be good for all of us. We are passing so many stress in Nigeria today. If we have one refinery working, it will reduce it. The next quarter next year, we get another one, it will reduce it. The next 1 year, then we get relief. So let us be optimistic. By God's grace, it will be okay. The question and answer, please let us hold it until we have the other two speakers, because our national chairman has whispered to me that he wants to go to Trinidad. And our KBC, we cannot hold him down here. So, so the two of them have to speak, but their own will not be too long, like the lead speaker. So let us patiently listen to them. Our KBC, we don't have the capacity and audacity to tell you to stand up. Okay, so that we just do it together. The national, let me introduce our national chairman properly. And the iron lady. Yeah. The go-getter. Ashifa. And any other good names. She's the fourth chairman of this chapter. So he's fully of grants since we started this chapter. And she performed credibly well when she was the chapter chairman. She built on what she did, as I told you. And we also building on what she did for us. As of today, is the current national chairman. And for your information, for those who don't know, the first lady to be national chairman of Ghana. If I want to, she's my close friend. If I want to continue, she will not talk. But let's allow her to talk. Thank you.
Thank you very much, Engineer Abdulganim Tiamiu, NIMechE. The KBS, we appreciate you, sir. Former National Chairman, President Engineer Yofani Mukwebelese NIMechE, Engineer Abdulganim Uwolabi, sir, my father, FNSC NIMechE, all the elders, the immediate past chairman of the Nigerian Society of Engineers Apapa branch, Engineer Christian Ufort, NIMechE, all other elders, members, ladies and gentlemen. I must say that the guest speaker done justice to the topic of asset management and maintenance, but I would just like to say a few words just to support what has been said. And I know that when KBC holds this microphone now, I'm going to go through another lecture. So let me make my own very, very short. My own will be very short. Mechanical engineering plays a crucial role in maintenance and management of national assets, which encompasses a wide range of infrastructure, equipment, systems that are vital to a country's functioning. So the lead speaker had spoken about the oil and gas basically, and I know that when KBC comes up, KBC is going to take the research, the design, the manufacturing, the fabrication, because he has the overall expertise in all those areas I've mentioned. Also in administration, because one of the things that we engineers lack is that we are very good. Mathematics, binomial equation, dy dx, everything is in our brain. Come design, come research, come repair. But when it comes to administration, when it comes to politicking to ensure that we get the job, it becomes difficult for us. That is why a lot of the lawyers are the ones getting the job, and they will now sub for the engineers. So that means that we have the call as role models, as key players in the industry. We shouldn't continue to take the back seat as engineers in terms of national asset and maintenance. It's our job, but we need to take it directly as our job. Not that lawyers, accountants will take it and sub to us as engineers. So we have a key role to play. And that brings me to the fact that we need to become more social. As engineers, we are not social because we feel that we have the brain. You know, I remember when we are younger, we cover our books when you are writing exam. And all the social people that write whatever they like, they will come out and they will be the ones, determining how we as engineers will operate. So it's a call to us this afternoon that we need to become social. Whatever we need to be involved in, we can be involved in them. I remember some few months ago, they made one of our engineers a top management in the oil and gas, and they gave him form for country club, they gave him form for Ikoyi club, and he said, "Madam, I don't even know anybody that goes to that club. I know you will know. Please help me get people to sign for me." Because it's compulsory with the position that is occupying that it must be members of those clubs. And he didn't even know a single person that he can say, "Oh, goes to that club and I need to." So it is important because we don't know where God is taking any of us to. So you have to be involved in all aspects of life. So here are some of the key aspects of mechanical engineering contributions to the field. Infrastructure maintenance, which is one of the key areas. When they picked a new essay, works now, and he's an electrical person, the infrastructure people started complaining, the civil started complaining that why should they pick an electrical. I said as mechanical, we are also part of the infrastructure maintenance. Maintenance of the M&E is not limited to, is the electrical, the wiring, the plumbing, the ACs, the cooling system. No, infrastructure maintenance is part of mechanical engineering. I had to enlighten them last week when I went to see the new essay. I said, no, it's part of what we do. But it's because we feel that infrastructure is basically for civil engineers. No, it's not for highway engineers. No, it's part of mechanical engineering. So mechanical engineers are responsible for ensuring the upkeep of critical infrastructures such as the bridges. Because I remember when we were in the university in UI, Professor Babiro taught us bending moments. Strength of materials. Is it not bridges? Is it not dams? So why do we keep saying that it's only for civil? So the infrastructure maintenance is part of our job, which we need to begin to look at more critically as mechanical engineers in nation building and national asset. This assess structural integrity, like he said something about integrity, which has to do with the oil and gas, but the structural integrity of the bridges, the roads, the dams, and around us has to do with mechanical engineers. The design repairs, the oversee maintenance programs to ensure that assets remain safe and operational. And then that brings me to the transportation system. I looked at the brochure, I saw that Engineer Toriola had written to the chapter, which means that transportation is part of mechanical engineering. Yesterday, a circular came out, and they said they have moved him to become the permanent secretary, Ministry of Housing. And a lot of people come yesterday and say, "Madam, you have to go and meet them. How can they move him to housing?" I said, housing is part of mechanical engineering. So he's still going to be doing his job there. Because mechanical engineering is versatile. So transportation system, we are involved in maintaining and improving transportation assets like trains, like planes, like automobiles and ships. So I want to put the question to us. They have brought more rails in Lagos. What is our chapter doing to ensure that we are going to be involved in the maintenance of those rails? We need to pay a visit to Lamata. Whoever is there right now, I don't know if Madam is still there. Bimbo, is she still there? I'm not sure. If she's still there, whoever is there, write as a chapter. And pro bono, we can give suggestions on how to maintain those things. And by the time you do it pro bono, before you know it, you are doing it, you are collecting money as a chapter. So it is important that we involve ourselves. They are not going to come and meet us where we are. Let's begin to assess. They have brought the blue rail. The plan for the rail is beyond the blue rail. We have the red rail, we have the orange rail, we have several rails that are coming up from different directions. How do we, as a chapter in Lagos, where that is happening, how do we involve ourselves in the maintenance of those things? It's a question to us this morning. So we need to work in everything from vehicle design and the manufacturing to maintenance schedules and safety inspection. Currently, as a national body, we are working on the conversion of petrol to CNG. a training had gone up in August. A lot of people, I know a lot of people come in, across Nigeria to say, oh, it was expensive, and we gave a discount to, mechanical engineers that are registered members for those trainings on CNG. And we have somebody else that came up and said, no, the number that was sponsored was too small. And the person that came to me was an electrical person. He said, Madam, I can put down 20 million. Go and get somebody that will come from outside the country, the equipment that you need to set up that in Nigeria here, so that we can do the conversion ourselves and we can have more than 1,000 people being trained to do the conversion. So it is part of what we do. And we need to be proactive as engineers. Like he said, most of the equipment are obsolete. How do we ensure? How do we come up with designs? How do we present ourselves to government? Last week, I was at the National Assembly. I met with the mechanical engineers at the National Assembly that are our members. Because I needed to speak with them. They are there, they are representing us. What do you want to do for us? And they are saying, what are you bringing to the table? So we need to come up with the design. They are the ones that will push them. And that's why we have them. We have like 3 of them in the National Assembly that are mechanical engineers, and they are willing and ready. So we need to also be ready to give them what is required for this national asset and maintenance for it to be effective. I'll go to the third one, which is energy generation and distribution. Mechanical engineers play a significant role in maintaining power plants, turbines, and renewable energy systems. We work to optimize energy production, reduce downtime, and ensure the reliability of energy infrastructure. There is a training that we're organizing that is coming up very soon, and we are partnering with the Glasgow Caledonian University on energy audit. As soon as it rolls out, we want our engineers to be involved in that training. You cannot give what you don't have. Things are changing every day all over the world. Are we moving with that technology to say, oh, I'm bringing this technology to Nigeria to change things here? Especially in the area of energy. We are partnering currently as a national body, we are partnering with McAlpha Incorporated. Their representative is Nigerian, Mr. Nufort is their representative in Nigeria, but the company is located in Canada, and we are partnering with them. Energy audit is part of the training. I think it's part of the training we are rolling out. Currently, we are working on the feasibility study on which areas do engineers need. So we'll be sending the forms to you in the next 1 week. The form is almost ready. It's being scrutinized in Canada right now, and it will be sent back to Nigeria to give to all mechanical engineers in Nigeria. As it comes in, feel the skills that you feel you want. What do you need to improve your skills as an engineer? You have at the basic of the university, you have mechanical engineer general. So the specifications, the area of the specification is what we are going into. And McAlpha Incorporated is working with us on that. So as we roll that out, please, we want you to participate in that. We are not doing it for only ourselves, we are doing it for mechanical engineers in Nigeria. Another area of national asset is the manufacturing and industrial asset. And I know that KPC will be speaking on that. It's essential that we do maintenance of machines, production lines, manufacturing facilities. They help to improve efficiency, reduce downtime, and ensure product quality that we produce as engineers. So it's another area for us to look at as mechanical engineers in terms of the asset maintenance. Defense and natural security. In the defense sector, mechanical engineers are involved in maintaining military vehicles. The person that is currently manufacturing military vehicles in Nigeria is not even a mechanical engineer. He's an electrical engineer. I've gone to visit the place. Any time you went with me now to Momas, where they are building the army.
Armored tanks.
Okay, yes, you went with me. Yes, he's an electrical engineer. No, he's on Lagos Ibadan. It's Asheshe. He's at Asheshe. They are building the bulletproof. They are building the military helmets. They are building the military vehicle, the armored vehicle. He's an electrical engineer, and he's building it. It's just the person building in the vehicle is even a chemical engineer. He finished from NIMechE Lag. I've met with him too. It's chemical. It's not even a mechanical engineer. And the person building on Lagos Ibadan at Asheshe, to be precise, that Pakuro Junction, is electrical. Engineer Bukola Balogun. So they are building armored vehicles, they are building the bulletproof, they are building the helmet for the military. So it's part of our work. And we need to also go there. I advise that Lagos chapter goes there also to see what they are doing. I've gone with the chapter chairman before to visit him. So if there is need, you can reach out to me. We'll visit the place. You see what the man is doing there, and he's an electrical person. It's our job. Environmental protection. Mechanical engineers often work on systems related to environmental protection and sustainability, such as wastewater treatment plants, which is part of, I know KPC is working on something waste disposal. He has a lot of machines that he has invented, he has designed on waste. So it's part of our job. Air quality control systems, renewable energy technologies is part of what we are doing, which is part of the partnership we have with McAlpha Incorporated in Canada. They are currently working with Robert Gordon University on renewable energy, which is part of what we are partnering with them on. Asset management and data analysis. Mechanical engineers use data analysis and predictive maintenance techniques to monitor the conditions of assets and schedule maintenance proactively, reducing costs and minimizing downtime. Then the other one is safety and compliance, which is what engineer value does a lot for us, the safety and maintenance, the codes and standard. Currently, we are partnering with LLNG. We have held 2 meetings with them as a national body of NIMechE, and the world valve engineer resides in LLNG. If you read from you, Ayokilani. Yeah, so we have held meetings with them. They are ready to actually work with us in our training academy on safety, maintenance, codes and standards for Nigeria. Because as the world engineer on valve, he said he has gone all over the world and Nigeria does not have a standard. And they are willing to partner with us as LLNG to ensure that we have those things. They will be coming to the conference to speak anyway. And we hope that before the conference, we'll have been able to inaugurate the Bonnet Island. We have approved the Bonnet Island. We are hoping that we'll be able to actually inaugurate them before the conference. Research and development, which is the key area for KBC. Mechanical engineers should be involved in that. In our training academy that we are building currently, R&D Research Center is part of what we are doing. We are not only doing it for ourselves, we are doing it for the country. If we don't involve in research and development, we are not going to go anywhere. So it's part of what we as engineers should spend our money on, research development. NASENI recently, last year, launched 500 million naira project on research and development for engineers that have ideas to come up with ideas. I was at that launching. And right now, because they have not settled, we are meeting with Korea to see how we can now sit with NASENI, with the new DG of NASENI, to see how we can come up with ideas that can actually change and improve Nigeria. The Agency for Raw Materials, they are already partnering with us. They are going to be at the conference. They are part of the sponsors of this year's conference to see the raw materials that can be used, that can be certified for production of some of the research that we come up with. So we are not sitting back. We are working and we are on course. Overall, mechanical engineering is vital for the maintenance and management of national assets, helping ensure their longevity, safety, and efficient production operations, which are essential for a country's economic and social well-being. So I want to say thank you very much for listening to me this afternoon.